Problem number 2 from the CAHSEE Math Realesed Questions simply gives us an expression, and they want us to find the value of that expression. And the expression reads 3 and 3 6/10 times 10 squared, or you could also read 10 to the second power. And they want us to find the decimal value. Now, some of you may recognize this as scientific notation. Scientific notation. It's a way of writing big numbers in a short form. And they want us to change it to its decimal form, the decimal notation. Decimal notation. Or the standard form. Okay. Even if we didn't know that this was scientific notation, we can still solve this problem because inside of the expression we see the symbol for multiplication, which tells us what to do. This symbol here says multiply. Multiply. And so all we have to really do is just multiply those two numbers. 3 and 6/10 times 10 times 10. 10 squared simply means take two tens and multiply them together. It's a power of 10. Okay, in expanded form, we write 10 times 10. In the exponential form, we simply write 1/10 with a little 2 on top. Okay, if we multiply 3.6 times the first 10, then we have the effect of moving the point to the right one place. Every time we multiply a number times 10, it moves its point to the right one place. So from 3.6, 3.6, we move the point one place. Okay, one place to the right, and now we end up with 36 times 10. We still have one more 10 to multiply with, so locate the new decimal point. Its new decimal point is here on the other side of the 6, and move it one more place. So now from the place where it used to be before, it will move one more place to the right, and we'll add a 0 in its new location. So now the answer is 360. And that in effect is the answer for this expression. It's 360. Okay, so now let me just say this in Spanish. En los problemas de preguntas ejemplares del CAHSEE, el segundo problema nos pide que cambiemos esta expresión a su valor natural o su valor decimal. Algunos de ustedes pueden reconocer que este es notación científica porque tiene una potencia del 10 y aquí tiene un número menos de 10 pero más de 1. Pero aun si no supiéramos que era notación científica, podríamos resolver este problema. Porque este problema simplemente nos está pidiendo que hagamos la multiplicación que está indicada aquí. So, es cuestión solamente de multiplicar. Y multiplicamos con 10 a la potencia 2, quiere decir multiplicar por 10 y luego otra vez por 10. Siempre que se multiplica por 10, tiene el efecto de correr el punto a la derecha un lugar. So, en este caso, el punto que estaba aquí se va a mover aquí y va a salir 36. So, ahora va a salir 36 por 10. Se corre otra vez el punto a la derecha al multiplicar con este 10 y entonces nos va a salir 360. Y esa es la respuesta. Y aquí se terminó el problema. Pero ¿Qué tal si nos hubieran dado una expresión un poquito más complicada? Si nos dan un exponente negativo, por ejemplo. Okay, now I was just mentioning in Spanish that this is the end of the problem. We have solved the problem. This is the answer. But what would have happened if they had given us another problem with a different exponent, perhaps a negative exponent? Suppose they gave us 3.6 times 10 to a negative 3. A negative exponent cannot be interpreted the same way as a positive exponent. That might be because we're not operating in a negative time, we operate in positive time. Now, don't let that throw you off. What I'm saying is that you cannot talk about repeated multiplication of a 10. It's more like the multiplication of the reciprocal of 10. The reciprocal of 10, let me write this for you. Reciprocal. Okay, the reciprocal of a number is another number that is upside down. It is the number but upside down. In other words, if you have 2/3 and you want to find the reciprocal of 2/3, you flip it around, you put the 3 on top and the 2 on the bottom. Now these two numbers are called reciprocals of each other. If you were to multiply two reciprocals, you will get a 1. That's the thing about reciprocals. Every number that is rational number has a reciprocal. So 10, for instance, has a 1 in the denominator. If I flip it around and I put the 1 on top and the 10 on the bottom, then I have formed the reciprocal of 10. This is my 10 and this is 1/10. And these two are reciprocals. So what 10 to the negative 3 means, 10 to the negative 3, let me write this down, really means 1/10, the reciprocal of 10, raised to the 3rd power. So this changes meaning and our interpretation. The negative exponent becomes a positive exponent, but the base becomes the reciprocal. So we do have to remember that little bit. Now, I know that this doesn't make a whole lot of sense at this point, but if you study exponents, you will see why it is logical and it makes sense. Okay, so later on when we study the rules of exponents, this would become a little clearer to you, as well as why 10 to the 0 power is really equal to 1. Okay, so back to this. If I have to multiply with 1/10, then 3.6 times 10 to the negative 3 power becomes 3.6 times 1/10 times 1/10 times 1/10. Okay, so it's 1/10 3 times. And if you don't like to multiply with fractions, you can change this to a decimal. This would be the same as 3.1 times 0.1 times 0.1 times 0.1, or 1/10. Okay, now multiplying with 1/10 has the same effect as dividing by a whole number 10. Dividing moves the point to the left, just like multiplying moves the point to the right, dividing moves the point to the left. So this is actually dividing by 10 or multiplying by 1/10, however you want to say it. So I want to say that I am multiplying times 1/10, and that makes the point move to the left instead of to the right. And for every 1/10, I have to move it one more place. So I would end up moving it 3 places to the left. So this is going to become 0.6 0, 0, 3, 6. Now remember, the point used to be here. Okay, and it moved now. Okay, let me redo it here in blue. It moved 3 places. 1, 2, 3. And here is where the new point will end up. So for every time you repeat the same factor, you move it to the left. So changing to a negative exponent makes the point go to the left instead of to the right, as it does with positive exponents. And so the answer for this would simply be 0.0036. 10.6 times 10 to the negative 3 becomes 0.0036, becomes a very small number. So the negative exponents represent very small numbers. Let me say this in Spanish. Cuando nos dan un exponente negativo, tenemos que interpretarlo de una manera poco diferente a el exponente positivo. Cuando es positivo el exponente, repetimos el 10, el número de veces indicado por el exponente. Pero cuando el exponente es negativo, no tiene sentido decir voy a repetirlo 3 veces negativas, porque no conocemos el concepto de las veces negativas, solo las veces positivas. Lo que vamos a hacer es interpretarlo de esta manera. La base cambia al recíproco del 10. Números se dice que son recíprocos cuando uno es volteado al revés del otro. O sea, si tengo 2 tercios, el recíproco de 2 tercios sería 3 sobre 2. Volteo el 3 para arriba y el 2 para abajo. O sea, aquí los estoy volteando al revés. El 10 sobre 1, que viene siendo este 10, porque es un entero, tiene un 1 abajo, entonces lo volteo al revés, pongo el 1 arriba y el 10 abajo, y formo el recíproco del 10. Ahora, en vez de multiplicar con un 10, voy a multiplicar con el recíproco de un 10. Eso es 1 décima por 1 décimo por 1 décimo, que en forma decimal sería 0.1, 0.1, 0.1. Si hacen esta multiplicación, van a sacar esto. Lo que pasa es que el multiplicar por 1 décimo es lo mismo que dividir por 1 10. Dividir por 1 10 es mover el punto a la izquierda en vez de a la derecha. Cuando el exponente es positivo, el punto se mueve a la derecha. El número de veces indicado por el exponente. Cuando el exponente es negativo, vamos a mover a la izquierda el número de veces indicado por el exponente, pero el valor absoluto del exponente, eso es. Entonces 3 veces vamos a mover el punto. Este punto se corre a la izquierda ahora. 1, 2, 3. Nos va a dar ahora 0.0036, y ese es el valor de la expresión, o ese es el número mostrado en forma decimal. Y ya terminamos este video.